15.1 vector fields. Let's start with number 1. Determine whether the vector field is conservative or no. I already choose this one, and let's check why. So the first step here, here's our function. The first step, we're going to distribute the function 8y to the power 5. So 8y is going to be 5 plus 1 is going to be 6 for the I 8, and 8 times 6 is going to be 48x y to the power 5 for the j. Write down everything in a component form. This is m and this is n. To find if it's conservative or no, we need to check my equal nx. So m with respect to the y is going to be 48 times 6 is going to be 48 y to the power 5. And with respect to the x is going to be 48 times 1, so it could be 48 y to the power 5. You see, n x equal my. In this case, it's conservative. So we're gonna check that. Just click in. We got a type. For number 2, I'm not gonna solve this one for you because you're gonna get exactly the same thing with the same number. But I'm gonna give you a hint for this one. Here on this part, for the 1 over square root of 1 plus xy, 1 plus xy, you can write down this to the rational exponents. It's going to be 1 over 1 plus xy to the power half. And you can write down this to the, move this one to the top. So it's going to be 1 plus xy to the negative half. If you want to work with this one, with the second part, you're going to use the product rule, or you want to keep it and use it as a quotient rule, it's fine. Both is going to be fine. So this part is just a hint for number 2, because you're going to get exactly the same number. For number 3, we have f to the xy equal 2y over xi, 2x squared over y squared j. Convert this one to the component form. So it's going to be 2y over x, 2x squared over y squared. This is m and this is n. The derivative with respect to the y, m to the respect to the y is going to be 2 over x. The derivative n with respect to the x is going to be 4x squared over y squared. These are totally different. M sub y is not equal to n sub x. So this is not. So we're going to choose not. Let's check. So we got it right. But if it is, you have to find the potential function. If it's not, we have to write down here D and E does not exist. That's it for this example. Let's move to number 4. Number 4, the same thing. We have to check if it's conservative or no. And then if it's yes, we have to find the potential function. So let's check number 4. Number 4 here. So here is our function. And the first thing we're going to do, we're going to do the same thing. We're going to distribute xe to the x squared 3y. Distribute this one here. Then it's going to be 2xy e to the x squared 3y I. And here is going to be x squared e to the x squared 3y for the j component. I always convert this one to the component form. It's easier to work. If you want to keep it like with the I and j, it's fine. So here's the component form. This is m and this is n. Let's find m sub y, which is with respect to that. Find the derivative with respect to the y. So it's going to be 2xy. The first one is the product rule here. So the first one times the derivative for the second one, which is the derivative for this one is the derivative for the exponents with respect to the y. So it's going to be with respect to the y 3 y, that's mean only 3, so it's going to be 3x squared. Plus the second one times the derivative for the first one with respect to the y, so it's going to be 2x. Now, 2x times 3 is going to be 6x squared, 2x Yep. So 2x times 3x squared is going to be 6. I'm missing the y here, because 6x cubed, and here is the y, e to the x squared 3y plus 2x e to the x squared 3y. So this is the m sub y. Now I need to find n sub x. So here is n sub x. So that means it's going to be, here's n, the first one times the derivative for the second one. So here's the first function times the derivative for the second one. The derivative of the exponent is going to be, with respect to the x, is going to be 2x 3y plus the second one times the derivative for the first one with respect to the x is going to be 2x. Let's multiply x squared times 2x is going to be 2x cubed. And 2 times 3 is going to be 6. And here's the y, e x squared minus 3y plus here's 2x e to the x squared 3y. Now, if you look to the my equal nx, that means this is conservative. So I'm going to choose this option. Now, if it's conservative, I need to find the potential function. Now, let's check the potential function. The first part, to find the potential function, we're going to do the opposite thing. We found the derivative here with respect to the y. Now I'm going to find the integral for m with respect to the x, dx. So here is m. Now I need to find the integral with respect to the x. So I'm going to let u equal x squared 3y. So du is going to be 2x 3y dx. Then everything here is going to be u. That means e to the u equal 2xy dx is going to be 2x. The left here is y, because I'm canceling only the 3, not the y. So the left 2x y dx. This one is going to be du over 3, which is this part with the y and dx. And e to the x squared 3y is going to be the u. Then it's easier to find the integral here. Take 1/3 out, eu du. The integral for eu is going to be eu plus c, a constant. Now let's bring back the u, so it's going to be ex squared 3y. We going to find the integral with respect to the x. That means our constant is going to be, it's going to be a function with respect to the y, because if you're going to find the derivative of a function with respect to the y, is going to be 0. So I'm just going to write down a function with respect to the y, which is the same thing to c. Could be a constant, is going to could be a term with respect to the y, or function with respect to the y. So this is the first part of the potential function. Now we're going to do the second part. The second part, I'm going to find fxy to the integral n with respect to the y. The opposite of what we did here. So here's the second part. So fxy is going to be the integral n dy. Here is n. I need to find the integral with respect to the y. So let u equal everything here, x squared 3y. Du is going to be 3x squared dy. Then divide by 3, cancel here. So it's going to be du over 3 equal x squared dy. That means x squared dy is going to be du over 3. And here is e to the y. Take the 1/3 out, integral e to the u du. Find the integral for this one is going to be 1/3 e to the u plus c. Now we're going to find the integral with respect to the y. So this one is going to be any function with x. That means our potential function, if you look at this part, is exactly like what we found on the previous one. Here, I forgot here the 1/3. This is 1/3 here, and here is 1/3. So 1/3 here and 1/3. That means here's our potential function. Then we have g of x and g of y. So in this case, we're just gonna write down a k, which is, we don't know, k is going to be a function with respect to the x or the y, or it's going to be a constant. So in this case, we're just gonna type here 1/3 and e to the exponents x squared and 3y. X squared, 3y. That's it for this example. You got it right. Let's move to number 5. For number 5, here's our function. We need to find the curl with respect and evaluate at this point. So the first thing, I'm going to convert our function to the component form, which is x squared z minus 2xz and yz. Then the second part, to find the curl, I'm going to write down, do the cross product, d, or the partial derivative with respect to the x, the partial derivative with respect to the y, the partial derivative with respect to the z. And here is the first component with respect to the I, so x squared z, and here's 2xz, and here is yz. Now let's check that. For the I, is going to be the derivative with respect to the y to this part, yz, minus, for the minus is going to be the derivative with respect to the z to this part. So minus the derivative, so everything here with respect to the y. Minus for the j, we can hide this part. So it's going to be the derivative with respect to the x to the yz minus the derivative of respect to the z to the x squared z. This is for the j. Now for the k is going to be plus the derivative with respect to the x to the negative 2x z, negative 2xz, minus the derivative of respect to the y to the x squared z. This is for the k. Now let's go back here. The derivative with respect to the y to this part is going to be only z. Now minus the derivative with respect to the z to this part is going to be negative 2x, because the z is going to be 1. This is for the I. For the j, here's minus the derivative for this one with x. There's no x here, so it's going to be 0. Minus the derivative with respect to the z is going to be x squared. This is for the j. The plus for the k, the derivative with respect to the x is going to be negative 2z, minus the derivative with respect to the y is going to be 0. Now let's simplify. This is z plus 2x for the I, plus x squared for the j, minus 2z for the k. Write down in the component form, so it's going to be z plus 2x, x squared, and negative 2z. Now let's evaluate at this point. So we're going to plug in x, y, z. So it's going to be 7 plus 2 times 3. And here's going to be 3 squared. And here's going to be negative 2 times z, which is 7. So it's going to be 13, 9, and negative 14. So we can write down the column with the component form. So I'm going to choose vectors, component form. That's mean 13, comma, 9, comma, and negative 14. That's it for this example. You're going to do the same thing with example 6. The main thing, I'm not going to solve this one because you're going to get exactly the same thing, the same variable, the same number. So check if you can find it's conservative or no. For number 7, let's check how we're going to solve number 7. For number 7, we have f and g, and they ask you, here is the function f and here is the g. They ask you, find the curl, and it's equal to the gradient times the cross product between f and g. So the first thing I'm going to do, I'm going to find, here is the function f, which is 1, 5x, and 2y. And g is x, negative y, and z. The curl for f cross g. First of all, f cross g is going to be, that's what we need to prove. We need to prove the curl of f cross g is equal the gradient cross f cross g. So f cross g, here is the I and the j and the k. I'm going to write down f, which is 1, 5x, 2y, and g, which is x, negative y, and z. So here's another mistake. Here, this is x. So now for the I, it's going to be 5x times z minus 2y times negative y, so it's going to be plus 2y squared. This is for the I. Minus, for the j, is going to be z minus 2xy. For the k, is going to be negative y minus 5x squared. For the k, I write down everything in the component form. So 5xz plus 2y squared and negative z plus 2xy, and here's negative y minus 5x squared. Now the curl for f cross g, here's ijk, and the derivative with respect to the x, the derivative with respect to the y, the derivative with respect to the z. I'm going to write down the first part here, the second part here, and the third one here. Now let's check for the I, is going to be the derivative with respect to the y to this part, minus the derivative with respect to the z to this part, minus for the j is going to be the derivative with respect to the x to this part, minus the derivative with respect to the z to this one. And for the k, we can hide this one, the derivative with respect to the x to this part, minus the derivative with respect to the y to this part. This is for the k. Now let's simplify it. Let's go back here. The derivative with respect to the y to this part, this is 0, so it's going to be negative 1. Minus the derivative with respect to this part for the z, so it's going to be negative 1. That means negative 1 plus 1 is going to be 0. For the j, it's going to be the derivative for this part with respect to the x. This is 0. It's going to be negative 10 x squared. Negative, be careful here. So this is negative 10x. And there's negative sign here, so it's going to be positive. Minus the derivative with respect to the z. This is 0. This is going to be 5x, negative 5x. And there is minus here, so it's going to be positive 5x. Now the derivative for this one with respect to the x, this is 0, is going to be 2y. The derivative for this one with respect to the y, this is 0, is going to be 4y, so minus 4y. 2, now combine everything, this is 0, 5x plus 10, 10x plus 5x is going to be 15, 2y minus 4y is going to be negative 2y. So this is the curl for f cross g. We have to keep going, and now we need to find the second part. If you look to this one, the second part, the gradient, which is, there's gradients for not x and y and z. The gradient by itself, that means it's the partial derivative with respect to the x, partial derivative with respect to the y, and partial derivative with respect to the z, because they didn't tell you find the gradient for f for x or y or z. So in this case, for the second part here, the gradient cross the product with f cross g. This is the gradients for f sub the derivative with respect to the x, the derivative with respect to the y, and the derivative with respect to the z. And F cross G is going to be here's everything exactly the same. So if you look to this part is exactly what we did here. So I don't have to do the same steps again because my result is going to be 0, 15x, negative 2y. That's mean the curl of F cross G, it's exactly the same or equal to the gradient times F cross G. So here in this case, we're just gonna type, I'm gonna go to the vectors. I'm gonna say it's 0, comma, 15x, comma, and negative 2y. That's it for this example. We got it right. That's it for the section 15.1.